So you see that EF-ER register was set to enable SVM, so this 4 becomes 5. And yeah, we are inside matrix. So we are going back to the machine which was just blue-pilled. As you saw, just like in Dino presentation, nothing happened. It just becomes blue-pilled and without any screen blink or whatever. So I'm scanning for hardware again, just to show you that the same hardware is available. We have Western Digital disk, NVIDIA graphics card, we have Realtek network card, and the same processor and whatever. So then we will check the IP address of this computer. And this is 192.168.1.206. So we are going back to the remote machine. Then we will try to connect to this. Oh, this IP address is 1.10. So we'll just send a magic packet just to show you that the kernel network backdoor actually works. So that those functions are hijacked. So we are sending magic UDP packet with string password with 0, written with 0. Yeah, we get information that the magic packet got received. I'll just show you that we can connect to this backdoor. So we are connecting using source port 10 to port 445. This could be whatever else. Source port number 10 is just a way of, it's just a magic port, right? So this is how magic packets are recognized. Magic port plus magic source IP. But I also can show you that the SMB protocol still works by connecting to this machine, so file sharing still works, although it uses 445. So it doesn't interfere with the standard operating system functionality. And one more thing I would like to show you is something special. So once we allow it to run for a few minutes, we get this funny message. Somebody tried to read EF-ER register from the guest. And the question is, do you have any idea who tried, what kind of application, what kind of process tried to read this EF-ER register? Any ideas? What? No. No, it was PatchGuard. It was PatchGuard. PatchGuard is this famous kernel protection by Microsoft, introduced for 64-bit operating systems, and every few minutes, like every 5 minutes or something, it verifies the it verifies the integrity of some code sections like ndis.sys code section, ntus-kernel.exe code section, integrity of IDT table, SDT table, and among other things, integrity of some MSR registers, like, for example, integrity of EF-ER register. So if we didn't intercept if we didn't intercept read MSR, PatchGuard would catch us. But of course, it's a generic technique. We don't care about PatchGuard. It's just that we bypass PatchGuard automatically, right? By just ensuring that guest cannot recognize that it is blue-pilled. So we get we get PatchGuard bypassing for free. One interesting thing to notice is that if we left this operating system for a few hours, we can see lots of calls from PatchGuard. And the funny thing is that those calls originate from random addresses. So PatchGuard from time to time is moving in memory, right? So to make it difficult for Metasploit guys to disable it. Okay, I distinguish between, well, I distinguish between two levels of stealth for blue-pill. Something I call blue-pill level 1 is something which should be undetectable even though the concept is known. So I just made the concept known, and still I believe it wouldn't be possible to create any practical detector for this kind of thing. But of course, because okay, so this is level 1. But now we have level 2, which should be undetectable even if I made the binary code public. So this would be about avoiding signature-based detection. Bluepill level 1 is everything we need for a targeted attack. Just because Bluepill does not, or Bluepill-based malware does not introduce any modification inside kernel. So, and if we don't know the code, we cannot just detect it, right? Because we cannot use any kind of technique, like standard technique to see if something is hooked or not, which would lead us to the code. It's just something which might look like a picture or whatever. There's no connection between kernel and this Bluepill code. So Bluepill level 1 is something which should be enough, more than enough in any targeted attack. And this is what I implemented. Bluepill level 2 is a future, has not been implemented yet, just because to implement it correctly, we need 2 more mechanisms. One of them is nested pages, which is going to be introduced by AMD somewhere in 2007, as I heard somewhere. And another one is IOMMU, which I heard that it is also going to be introduced somewhere in 2007. But Bluepill level 2 is something interesting from theoretical point of view, and Bluepill level 1 is just because we can generate Bluepill level 1 code in many different ways, like we can use a polymorphic compiler for this. This is something which is the real threat right now. Like I would never consider, if I was an attacker, I would never consider using Bluepill level 2 just because it would be too complicated and just doesn't offer any more features over Bluepill level 1 instead of, well, despite the fact when we use it in a massive attack. Okay, so generic Bluepill detection. I just thought about this timing analysis, and then we can cheat about it by using this TSC offset field. And I said that the only practical way would be to use NTP or other NTP-like system, but it seems problematic to me. So you can ask if it's possible, maybe, to create something like red pill, but this time for this Pacifica technology. It might be possible. It might be like Pacifica might be buggy. I say buggy in apostrophes just because AMD documentation doesn't really say that they offer 100% virtualization. They only talk about secure virtual machine. But still, everybody believes that hardware virtualization can be used for for full virtualization. And if we had a way to create program which would behave differently inside VM and outside VM, this would mean that actually we don't have a full virtualization, right? So I would call it a bug in this SVM technology. But I stress that this is bug in apostrophes because it doesn't necessarily mean that the security can be subverted. It only means that it's not really 100%. It's not really a 100% virtualization in this case. But of course, I'm not aware of any way how to create red pill for SVM. Although I heard from a trusted source that there are some bugs, implementation bugs there, but it's just a gossip. We also researched together with Alex Tereshkin some theoretical ways how to detect Bluepill level 1, which are not based on timing analysis. And it seems that the only one way would be a very smart brute force attack, which would allow for crashing the system when it is blue-pilled. So we run the detector, and we say to the user, watch for the system. If you see a blue screen, then it means that you had a blue pill, right? Of course, it's something which this is something which sounds very unpractical for me, but this is a theoretical way to detect it. We haven't implemented it yet, but we'll probably do this. It's a brute force attack, well, but still.
That's what PatchGuard does.
Well, PatchGuard is not really detector. PatchGuard is something which should be, which is intended to discourage vendors for creating applications in a inelegant way, right?
Still blue screens when it detects.
Yeah, but this is it's not meant to be a detector. It's meant to force the independent software vendors, like personal firewalls developers, not to use tricks which they shouldn't use. Because if they use it, then they would notice that the system crashes every 5 minutes, right? So it's not really for the user. It's not really for use by corporations to detect the integrity of their networks. It's for discouraging independent software vendors from using forbidden techniques, which they shouldn't use. And by the way, I think that PatchGuard is actually a very good thing, because like I spent many years on writing different rootkit detectors, and one of the biggest problem I had was to distinguish between some personal firewalls and rootkits in a generic way. And I think it was in the first talk today by Jamie Butler, it was mentioned that sometimes it's virtually impossible to distinguish if it's personal firewall or rootkit, just because the same hooking technique is used. So this is crazy, right? So I really support Microsoft with this idea of PatchGuard, because we should really get rid of this. We should really, make our operating system more elegant. Because now, like SVV, which I released a year ago, suffered from so many false positives just because of this reason. So currently, the only good way for detecting rootkits is something which combines generic detection with signature-based detection. And of course, I hate signature-based detection because this is so bad idea, right? So this is so wrong that we have those personal firewalls or antivirus products which use those rootkit-like techniques. So we should really get rid of them. And by the way, this brute force attack, which I mentioned, which could be used to blue screen machine once it's blue pilled. So one of the advantages of having blue pill level 2 would be that it shouldn't be possible to have similar attack against blue pill level 2. But still, we think that it might be possible to come up with another brute force attack, which would be possible to crash the system, which is blue pill level 2, when some very special conditions when they will be met, like user removing SATA disk driver in some specific moment during some specific tests.